Good morning, how are you doing? I am Mr. Ish. You are joining me for this easy and interesting video. Perhaps not so easy, but I hope it will be easy. This video on sectors. If you start with a circle, you know, area over here is always pi r square. You have a radius always emanating from the center, and the circumference of the circle is always 2 pi r. The only difference between a circle and a sector is that of a proportion and a fraction. Sector is always a fraction of a circle. And by what fraction is it? It's always theta over 2 pi, because you're taking some fraction of the whole. If a whole circle is always 360 degrees, which is 2 pi, you do a fraction of that. A theta can be a fraction, everything here in radians. Then theta over 2 pi represents a fraction for which the sector is with regards to your circle. So if you have the area of a circle and you multiplied it by this fraction theta over 2 pi, you'll easily get to the area formula of a sector. You'll have pi r squared times theta over 2 pi. The pi's will cancel out. You'll get a half r squared theta, which is the area formula for a sector. We will tell you the area of this entire sector. Now, if you take the circumference, which measures the outer perimeter of a circle, and you multiply it by this theta over 2 pi, you'll get the arc length of a sector. And let's do that. 2 pi r times theta over 2 pi. The 2 pi's cancel out, you get r theta. But what exactly is the arc length? It's the distance of this outer boundary of a sector. That's your arc length, and it symbolizes an S. S, the arc length, is always equal to r theta, meaning the circumference of a sector is equal to r times theta, and I've shown you that the area of a sector is equal to half r squared theta. So given this, let's look at two questions in this video. A circle has a radius 2 over 3. We can start with the circle over here and draw a radius, and we'll call that 2 over 3. A certain sector is generated from here by an angle of 60 degrees. If you do a 60-degree angle, we generate a sector, and we are looking at the area of this sector. Find the area generated by an angle of arc of 60 degrees. Also find its arc length right over here. You know we have to convert this into radians. If you have 60 degrees, you multiply it by pi over 180. You can convert this into radians, which is pi over 3. And that's that part. Area is equal to half r squared theta. You just plug in the information. Radius here is 2 over 3. You have to square that times pi over 3. You'll basically get 4 pi over 9 times 3 is a 27 times 2, which is a 54. But you can simplify it. You'll have a 2 pi over 27, and that will be the area of this sector. How about the arc length, which is right here? S is equal to r theta. You have 2 over 3 times pi over 3, and that will be 2 pi over 9. And this question over here is done. Now the second question over here for this video, I promise you will be interesting, and it will be slightly challenging. We have a sector drawn over there, and we have to find two things. We have to calculate the area of that shaded portion. You know, this right here, this band is a shaded portion. We have to calculate that area, and then we have to find the arc length of the shaded portion sector, which would be this right here, this inner band. We would have to find that. How do we go about doing this? If you look generally at this entire sector, what would be the area of that one sector as a whole? You know, the radius is 1, the angle over here is pi over 6, which is 30 degrees. You could just run it through the formula half times 1 squared times pi over 6. This is just for perspective only. We get a pi over 12. The area of that entire sector is a pi over 12. But we're more interested only in the band. If you draw this around here again, look at it, what we have. We have this entire portion is 1. Then we know we have this band in between. From this point right up to this point, we know it's 3 over 4. If this entire band is a 1, and from here to here is 3 over 4, then this remaining portion is a 1 over 4. Likewise, from this point to right here, we have a 3 over 4, of which now we know this right here is a 1 over 4. So 3 over 4 minus 1 over 4 tells me that this portion right over here is a 2 over 4, which is a 1 over 2. And that's this band right over here. This band right here, now we've determined it to be 1 over 2. And this portion right here must be a 1 over 4, because 1 over 4 plus 1 over 2 will give me that 3 over 4. What we can do is redraw this portion of the sector, and let's do it. And nothing here is drawn to scale. I'm only drawing the original portion of the sector we have over there. We know from here to here is a 1 over 2. From here to here is 1 over 4. Again, not drawn to scale. If you did the entire area of this portion of the sector, we're not looking at this rest which came out over here. We're not worrying about that anymore. If we just did the total area of this sector and minus that from this smaller sector, that'll give us the area of the shaded portion. So what's the total area of this sector? This sector has a radius of 3 over 4. It would be area is equal to half times 3 over 4 square times theta, which is pi over 6. You can calculate this out. You'll get a 9 pi over 16 times 6 times 2 will be 192. That's a 9 pi over 192. That big portion here. Now let's do the lower portion. The smaller portion, this area is going to be, now we still have that 1 over 2 from the formula half r squared theta. The radius here is 1 over 4 squared times pi over 6. What is that giving you? That's giving you a pi over 192. So this entire portion is 9 pi over 192, this smaller portion is a pi over 192, and the difference of the two would be 9 pi minus pi, and it would be 8 pi over 192, representing the area of this shaded portion, which is what we're interested in. And that portion is done, the first part. Now we look at the arc length. The arc length calculation is very easy. Again, I'm only going to draw this portion of the sector, or the shaded portion right here, the band. We're looking at this arc length determination right here. You don't need to worry about anything from here to determine that. Arc lengths are always generated from the center of the circle. So this entire length over here is a 3 over 4. And the formula is S is equal to r theta. You already have everything you need. 3 over 4 times theta pi over 6 is a 3 pi over 24. And that's a pi over 8. And that gives you your arc length right here. From here to here is a pi over 8. You didn't have to start doing from 1 over 2. If you use the radius here as 1 over 2 and you fed that in here, 1 over 2 times pi over 6, your answer would be wrong. Because when you're doing the arc length determination, go to the center and extend out from there, and that's what you're looking at in terms of your arc length. Because for all you know, your original sector could have been just this portion right over here, for which then the radius would of course be 3 over 4, and you'd have the theta, and you get your arc length determination. So this right here is a good answer for the arc length of this shaded portion, or the band sector. And this 8 pi over 192 is the area of this banded portion of the sector, and then pi over 12 represented the area of the entire sector. And with that, we end this video. I hope you enjoyed this video. Stay tuned for many more interesting videos. Thank you for watching. Have a nice day.